In our first section of Math 110, we're going to cover section 1.1, which is on circles. We begin by covering the distance formula, which gives us the distance between 2 points in the xy plane. Suppose we have 2 points, we'll call the first one x1, y1, we'll call the second point x2, y2. The distance between the 2 points is given by d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This formula is actually a consequence of the Pythagorean theorem. If we plot 2 points in the xy plane, let's say that this is our first point. I'll say that it has coordinates x1, comma y1. Let's pick a second point. We'll say that it has coordinates x2, comma y2. If I connect the 2 points via a straight line, the length of that line segment is what we call the distance. That's what we want to compute. We can compute the distance by forming a right triangle by drawing a horizontal line and a vertical line like this. Let's call this side A, we'll call this side B. We know that according to the Pythagorean theorem, the sum of the squares of the legs, meaning a squared plus b squared, is equal to the square of the hypotenuse, which in this case would be d. Okay. So that comes from the Pythagorean theorem. If we look at the length of A, on the x-axis, it's going to be this distance here, which would be x2 minus x1. That's the length of A, and it should be squared. Plus, if we try to look at the length of B, notice that that's just going to be the difference of y2 and y1. That gives us this length. So this is y2 minus y1 squared is equal to d squared. And then to solve this for d, you would simply take the square root of both sides, and that leads us to our distance formula. Let's use this in an example. Let's find the distance between the 2 points 7, 12 and 4, 8. So we'll call the first point, let's call that point 1. So that's going to be x1, y1. And the second point is going to be x2, y2. Again, that formula, the distance formula, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So write out the formula. The next step is just very carefully plug everything into the proper order. This is going to be 4 minus 7 squared plus 8 minus 12 squared. A little bit of arithmetic, order of operations, we do what's in the parentheses first. This is going to be negative 3 squared plus negative 4 squared. This is going to be the square root of 9 plus 16. That's going to be the square root of 5, which is equal to 5. So the distance between those 2 points in the xy plane would be 5 units. Let's take a look at the next example. Let's find the distance between negative 1, 0 and 3, 5. It doesn't matter which point you call point 1 and which one you call point 2. The distance between 2 points, regardless of the orientation, is always going to be the same. So as a habit, I usually call the first point that's listed point 1. We'll call the second point point 2. And again, let's plug those into our distance formula. We get the distance is going to be equal to the square root of x2 minus x1. So that's going to be 3 minus a negative 1 squared plus, now we're going to do y2 minus y1. That's 5 minus 0. That again has to be squared. We have everything plugged in. Let's work this out, order of operations. 3 minus a negative 1 is the same thing as 3 plus 1, so that's going to be 4 squared. Plus over here we have 5 minus 0 is 5, so that's going to be 5 squared. We get that the distance is equal to the square root of 16 plus 25, and then 16 plus 25 is going to be 41. Okay. and this would be our exact answer. It's exact because 41 is not a perfect square root, nor is 41 divisible by a perfect square, where there would be any potential ability to simplify or reduce that radical. So that would be the exact answer. And for the majority of the questions and on the exams, I want you to all to put our answers in exact form. However, if this would be like some kind of applied problem, or maybe you actually need an exact measurement, then you could go ahead and approximate it. If you punch this into your calculators to 2 decimal places, this would be approximately about 6.40. Okay, and that would be an approximate answer. Okay. For us, the goal is right now, unless otherwise stated, always leave your answers in exact form for distances, meaning simplified radicals. The next thing we're going to come to is the definition of a circle. So we all are familiar with circles from the past. We see circles every day. But what a circle is, the proper definition is it's the set of all points that are equidistant from a fixed point. Okay? And that set distance is what we're going to refer to as the radius. So you fix a point. We define that point to be the center of the circle. And we're going to assume that it has coordinates h, k. If I want to find all of the points that are, let's say, 2 units from that center, we're going to call that R, the collection of points that it would be generated would be what's in this kind of like bluish circular part here. So it's very important that the actual circle itself, it consists of these points on the rounded curve. The center is used in the definition, but technically speaking, the center is not a part of the circle. It's not in the collection of points. To come up with the equation of the circle, let's suppose we have an arbitrary point. Let's call it x, y. What do we know about x, y? Well, we know that its distance to the center has to be r units. So this is something we could actually plug into the distance formula. The distance, in this case, our fixed distance r, is going to be equal to the square root of the differences in the x coordinates. Let's call this x minus h squared plus the differences in the y coordinate squared, y minus k squared. And then it's common practice that usually whenever you see the equation of a circle, usually people will square both sides to put it in the following form. And this is the equation of a circle. It's actually a consequence of the distance formula. So the standard form of the equation of a circle, so let's suppose we have a circle whose center is at h, k, and it has a radius of r. It's going to be x minus h squared plus y minus k squared, quantity squared, is going to be equal to r squared. Okay. So in the standard form, notice that you want to have a square quantity on the one side, and then you want to have parentheses with both an x term squared and a y term squared in it. Okay. Let's take a look at example 1. They ask us to write the standard form of the equation of a circle with center 4, -3 and a radius of 4. So first things first, we pick up on that buzzword standard form of the equation of a circle. So we know that that means the following formula: x minus h squared plus y minus k squared is going to be equal to r squared. Okay. Where our center is 4, -3, that makes h equal to 4, k is going to be -3, and our radius value is 4. We're going to go ahead and nice and neatly plug those in. We have x minus h squared plus y minus k squared is equal to r squared, which is 4 squared. And then to finish this off, the only thing we want to do is simplify any potential double negatives like we have in here. So we can rewrite this as x minus 4 squared plus y minus the minus is going to become a plus 3 is equal to 4 squared. And again, we don't want to write this out. You could write this as 16, but it's more convenient to have it with that square on the right hand side, just so that if somebody looks at it, they can very easily recognize that that radius can be equal to 4. So that would be the standard form of the equation of our circle. Let's do another one of these. Write the standard form of the equation of a circle with center 0, 0, and radius 7. So this is going to be x minus h squared plus y minus k squared is going to be equal to 7 squared. X minus 0 is still x, so we're going to get x squared plus y minus 0 is just y squared equals to 7 squared. And that would be the standard form of that circle. The circle who has a radius of 7 and center 0, 0. Let's take a look at this example. It says, given the equation of the circle, determine the center, the radius, and the graph of the circle. Okay. So first thing we would notice is that this circle is very nearly in standard form, with the exception of we would want to see that right hand side as a number squared. We know that 16 is the same thing as 4 squared, so we can write it like this. Now that it's in that form, we can go ahead and identify the center. It's going to be 3, 1, and it has a radius of 4. So the center of the circle is 3, 1. The radius is the number that's being squared on that right hand side. So the radius is equal to 4. And they also ask us to graph the circle. Now that we know the center and the radius, we should be able to go ahead and graph our circle. Going to nice and neatly make some xy coordinates. Here's y, here's x. The center is at 3, 1, which should be right here. So that's our center. And now we have a radius of 4. So what I would recommend doing is simply go 4 units to the right. We can also go 4 units up, 4 units to the left, 1, 2, 3, 4, and then also 4 units down, 1, 2, 3, 4. That'll give us kind of our boundary points there, and then just as best you can, try to very nice and neatly draw your best example of a circle. And that's not the best circle I've ever seen, but you get the general idea. The center is at 3, 1, and it would have a radius of 4 units. The next thing we're going to look at is the general form of the equation of the circle. And the way in which the general form differs from the standard form is that in the general form we don't have any parentheses. Everything is completely multiplied and distributed out, and we have one side set to 0. Okay, and then typically the order of the terms should go like this. You have your squared terms first, so you have an x squared and a y squared term. Then you're going to have some x term with its coefficient, some y term with its coefficient, and then a constant term of f here. Let's take a look at example 1. They want us to write this standard form circle in general form. To begin, we notice the general form does not have any parentheses, so let's go ahead and distribute and expand these. Remember, when you square a binomial, x minus 1 squared means to take x minus 1 and multiply by x minus 1. Same thing here, y plus 1 squared means that we need to take a y plus 1 times another y plus 1, and on the right hand side this is equal to 6. Use your distributive property or FOIL it, whatever you like to call it. You need to distribute this out. If you do so and combine your middle terms, this first parenthesis will produce an x squared minus 2x plus 1. Plus over here, again, we need to distribute this one out. Again, FOIL or distribute. Combine like terms, you're going to get y squared plus 2y plus 1 equals to 6. The very next thing we want to do, now that we've eliminated our parentheses, is that notice the right hand side of our standard form, of our general form, should be 0. So we don't want to have the 6 over here. We're going to ultimately subtract 6 from both sides. But before doing so, let's start to write it in the form that we need. We're going to put on the left hand side, let's rearrange it. We're going to put our x squared term first. Then we have our y squared term. So x squared first, then y squared. The next term we should be listing should be the x to the first power. That's a negative 2x. Then our y term, we have a positive 2y. And after we expanded those, notice we do have some like terms on the left side. A positive 1 and a positive 1. We'll add to make positive 2 equals to 6. And then our very last step would be to make the right hand side 0. Now we're going to go ahead and subtract 6 from both sides. And here's what we have. We have x squared plus y squared minus 2x plus 2y, and then positive 2 and a negative 6 will combine to make a negative 4, and on the right hand side we have 0. And so this would be the general form of the equation of a circle. Oftentimes, especially if you are working with equations, this is sometimes how you'll be presented with the equation of a circle in general form, but it's not quite as instructive as what the standard form is. A lot of times the standard form is ultimately what we want for a lot of these things, because at least in the standard form you can actually visually look at it and see what the center and the radius is. When the equation is now in general form, we're not able to visually look at it and glance off that same information, but nonetheless this is what that form would look like. The next thing we want to do is now kind of go backwards. Let's suppose we have an equation that's in general form. So if you look at this expression, this is general form. Right? And we want to write it in standard form. So our goal is to take this thing and write it in the form x minus h squared plus y minus k squared equals to r squared. Okay, the first thing we're going to do this is let's move that constant over. So we're going to take any constant over to the right hand side. We have x squared plus y squared plus 6x minus 8y is equal to 4. The next thing we're going to do is on the left hand side, we're going to get our x terms together and we're going to get our y terms together. So let's group or kind of associate. Here's all of our x stuff, and now here's all of our y stuff. And now what we want to do in each of these groupings is we want to complete the square in both the x and the y variable. The way completing the square works is as follows. If you have the expression x squared plus bx, we can complete this to a perfect square by adding the following thing. You take the coefficient of the x to the first power term. You take half of it, so you divide it by 2, and then you square that. Okay. So if I add b over 2 squared, here's what happens. This would give me x squared plus bx plus, this would be b squared over 4 if you want to multiply it out. And this thing actually factors as x and x plus and plus b over 2 and then b over 2. Which is a perfect square. It's x plus b over 2 squared. Okay. So essentially, when you add that completing the squared term, that half this coefficient of x divided by 2, it will factor as a perfect square binomial, and what's going to go in that parenthesis is going to be x, whatever sign you have here will be the sign that goes here, and then it's the thing that's being squared, the b divided by 2, that will be in that parenthesis with it. So let's come over here, let's complete the square in the x variable. So to complete the square in the x variable, I noticed that we have a coefficient of 6 here. So this coefficient of 6, if I can highlight it, maybe I can't, but I got a way to do it. So here we have a 6. So what we would do is we would take half of 6, and then we're going to square it. Half of 6 is 3, and then 3 squared would be 9. So to make a perfect square trinomial inside of this parenthesis, I need to have a positive 9 added into it. Now keep in mind, in the general scope of things that's going on here is we have an equation. And we know that whenever you work with an equation, whatever you do to one side, you also have to do to the other side. So if I add 9 on the left-hand side, I also need to add 9 on the right-hand side. Let's now complete the square in the y variable. So if we look at the coefficient of y, the coefficient of y is negative 8. So we come over here, we need to take half of negative 8 and then square it. Half of negative 8 is negative 4. And then negative 4 squared is going to be 16. So to complete the square on the inside here, I need to add 16. And if we add 16 on the left-hand side, then we also need to add 16 on the right-hand side. As a result of this, we should now have perfect squares in both the x terms and y terms. X squared plus 6x plus 9, that factors as x plus 3 quantity squared plus y squared minus 8y plus 16. That factors as y minus 4 squared, and this is equal to, on the right hand side, 4 plus 9 plus 16, well, that should be 29. And notice again that one of the ways that might help some of you, if you pick up on the pattern here, if you look at what's happening, again, what you get with each variable, whether it's the x and the y that goes inside of that binomial part, is exactly the thing you had before you did the squaring part of it. So before I squared to get 9, I had a 3 under a square. That positive 3 is going here. Before I squared to get the 16, I had a negative 4 under a square. That's what's going to go in this parenthesis. And then last but not least, we do want to write the right-hand side as something squared as well. Well, 29 is not a perfect square, but you can just say that it's the square root of 29 getting squared that would give you that equation. And then just to summarize, this would now be our equation of our circle, but now it's in standard form. And they don't ask us for this, but very easily, now that we have it here, we can identify the center. The center of this circle would be at what would sit behind a subtraction sign here. So that's going to be a negative 3, comma 4, and the radius of this circle, would be what's under the square here. So it has a radius equal to the square root of 29 units.